All right, excellent. So this is my second follow-up meetup to a previous meetup we had on firepower. This is kind of an introduction of firepower, but we're digging deeper into layers each time we do this. This time I'm kind of, it's not going to be the longest meetup, but just going over here, I'm going to pull this up on the screen. Some of the things I wanted to kind of go over were, we did talk about some of these before, but we didn't really go through the configuration deep or talk it through. We're going to talk about security intelligence, object management, custom applications, the configuration of SSL decryption policies, DNS policies, and advanced malware protection, or AMP. So this meetup is going to be solely focused on these and the configuration of and kind of some of the background and things that happen under the hood. The next meetup I'm going to have for this, in this line, is going to be, we're going to be digging kind of a bit deeper into intrusion policies. There's actually a lot more detail we can go into in that regards, layering the policy, some of the things that we can do to kind of manipulate the snort rules and just kind of apply them to certain networks or certain things. So that's going to probably eat up the lion's share of this next one that's coming up. We are also going to talk about PX grid integration with ICE and rapid threat containment with firepower and ICE. If anyone's ever heard the marketing term with Cisco, it's fire and ICE. But in reality, ICE actually does integrate with quite a few products out there. I can actually pull up my demo lab really quick and show you. It's not only Cisco products, but Cisco products, obviously, we do make our products to integrate in terms of security. So just giving you a sneak peek into some of the things that we'll talk about next time, and we'll configure eventually between the firepower courses and the ICE courses, is this PX grid integration. And then this is ICE 2.1, by the way, so anyone who's seen older versions of ICE, I'm sorry, the GUI wasn't particularly pretty, and ever since ICE 2.0, the GUI's been getting dramatically better. Some of the different integrations we'll kind of go through in other sessions is that PX grid integration, which you can see here I have in my lab, my WSA integrated with ICE, Stealth Watch, Firepower Management Center. So, and not only does this share like identity information, kind of like how you would do like a context directory agent, but you can also use this for mitigating threats. So let's say if you wanted to create a policy in Firepower, if you see a certain level of event, you can actually take action, like an intrusion event or a malware event, you can have that ICE take action and quarantine that user off the network, whether that user's VPN'd in or they're actually attached to your network. It'll punt them right off if you want, or you can give them a different level of access. So we will go into these between my ICE session and the next Firepower session. Next Firepower session, though, we will definitely focus on this in terms of how it relates to Firepower, obviously. And we're going to talk about the network analysis policy next time as well. This one is not something you would configure on a day-to-day, or most times the default is good, but we are really going to dig into the details so you know some of the things that you could can kind of use and tweak, and what you might tweak. Obviously, there's some settings in there for things like sub 7 or back office for anyone who was on the internet in the 90s. Those ones might not apply to your environment as much, but there are some like web HTTP ones that definitely could apply in some situations. We'll also talk about correlation and remediation policies. These are kind of like PX grid integration. It ties in there, but these are policies that you can take an action on if Firepower does detect something. So it could be something as like simple as a new host is discovered and it runs an Nmap scan to kind of learn more about that host. If an intrusion event happens, or that host, a certain kind of intrusion event, it could send it can actually send a config to your router or your switch. It basically null routes that IP address for that specific host. So there's kind of some different things you can play around with. And of course the identity policy, which does tie into ICE, but it also ties into how you would integrate this to your domain. So those are some of the things. And if I think of anything else between now and the next time, I will definitely bring it up and add it to that meetup if you guys are interested. If anyone has any requests as well, since it'll be our last main Firepower meetup, I'm open to anyone sending me an email. My email address, just so we can get out of the way, if anyone wants to screenshot this, my email address is McNamara 013 at gmail.com. If there's something specifically you wanted me to go more in depth with or configure for the next meetup for Firepower, might as well send in the request and I'll see what we can do. So hope you guys got that, but I'll add it to the meetup comments as well if anyone missed that. So the first thing I wanted to talk about was security intelligence. Now, we briefly talked about that in our last meetup, and I mentioned that it was kind of a feed from Cisco's security research group. Now, giving you a little bit of background, Cisco Talos is that security research group that sees something like 1/3 of the internet traffic just based on all the devices out there, Cisco devices out there and traffic it sees flowing through them. And based on that, they see a lot of the different files. They see when new malicious domains are created or malware as it comes propagates through different networks, it does start to see that and detect it. So one of the tricky things malware typically does is they used to hard code your IP addresses in. So when that malware is executed on a domain or on a computer, it reaches out to that IP address. But it was too easy to report those web hosts to whoever the web provider was or the ISP was and get them punted off. So what virus writers start doing is they start utilizing garbage domains. So maybe they'll have like a program that creates like a garbage, like 20 character long garbage domain, and they create that, and that's what the malware tries to reach out to. And they can just, all they have to do is they get kicked off their domain server their web host, is they just have to change the IP address and update DNS. So what security intelligence does is, in the past, Talos used to send a feed of just IP addresses as they were determined to be malicious. Since I believe it was Firepower 6.0, they actually updated it. So now it's not only a feed of URLs or IP addresses, it's URLs, DNS information. So if there's a malicious DNS provider out on the internet somewhere, or because one thing malware does sometimes do is it changes your DNS to reach out to the internet to one of these malicious DNS servers, and that DNS server will redirect all of your anything you try to reach out to, Yahoo, whatever it is. That computer tries to reach out and it'll get forwarded to a malicious, it doesn't matter what they're trying to reach out to, it'll return with an IP address to a malicious CNC server or something that will download more malware. So using the security intelligence feed from Talos, it's able to kind of stay ahead of that, because a lot of us don't have a security research team at our disposal. If my experience with separate companies and their security teams, and maybe your guys is out there, is you probably have a smaller shop. You may have a couple people dedicated to security, but you don't have someone constantly going out there and checking for malicious, feeds of malicious software and DNS IP addresses. That's kind of somebody else's job to do. So what Talos is they kind of take that job and they update your devices constantly to, I believe the default is 2 hours And what you can do is you can have those URLs automatically blacklisted in Firepower. So before anyone tries to reach out, before any IPS policy gets applied to that in your access control policy, it's blocked from even reaching out to the internet. And it's before any other access control rules. So the cool thing also in here is you can create your own feeds, or you can upload a list of you if you don't want to create a feed. So I'm going to take you through really quickly how to create your own feed, and you can see where inside Firepower you can kind of take a look at those existing feeds. So as you can see here, in old versions of Firepower, you just had this network lists and feeds, and that's the IP address lists and feeds. The difference between a feed and list, obviously, is a list is something static. It's something that is uploaded once, and you can re-upload again, but it's a manual process. A feed is something Firepower will reach out to and update at intervals that you specify. By default, going into this network list, I see the Cisco Intelligence feed, and I can see how often it's updating by just clicking that pencil button, and the default, as I said, was 2 hours. You can increase the frequency of it, obviously, or you can delay it if you have bandwidth issues at a certain site. I could understand that. Another thing that's in here by default is the global whitelist and blacklist. Those are things that you can add in manually as well. Another thing you can do, I mentioned before, is you can create your own list or feed. So if I wanted to say, you know, I'm a part of a security team, and it's not even a certain, like a malicious host. Maybe there's certain businesses or IP addresses I don't want people being able to reach out to. I can go ahead and either update a SharePoint site and direct this to there to download that constantly, or I can just upload a static text file. I'll just create a list of IP addresses and put them right here. So if I do list, all I have to do is upload this text file right here, and it'll automatically update that for me. If I want to do a feed, I can also specify the URL that feed goes out to and the update frequency, just like the Talos feed. Now, just by creating these feeds, bear in mind I'm in the object management section of Firepower, so this is not actually applied to a policy. It doesn't block or whitelist things until I actually define them in the actual access control policy. Another thing you can use these feeds and lists for is whitelist policies. It's not just blocking. So let's say you have a certain set of companies that you work with, and you never want anything being sent to them to be inspected or or blocked in any way. You can whitelist them through security intelligence, and basically that communication, at least the initial connection, is not going to be blocked based on anything that this Talos feed or any other feed is going to put in. And as you can see here, I can go through DNS lists and feeds, URL lists and feeds. You do have some flexibility here. Let's go ahead and take a look at the policies in the access control policy. So the access control policy is the main place where you can kind of configure what you're going to be doing with the security intelligence. So this is the one that's currently applied to a 5506, and I am actually taking action. So if anything I update here, I can go ahead and block or not block. If I wanted to blacklist routergods.com, for example, I'll kind of walk you guys through and show you how that works. But right here, these are all the Talos feeds that are automatically updated. I can just, by default, they're not in the blacklist. You have to manually choose that, so add that to your blacklist, like I do here. Now, if you have a feed, you don't want to block these by just putting them in the blacklist. You do have the option to kind of test it out first. All you have to do is right-click the type of feed, and you can do monitor only, don't block. What this will do is it will send you an alert saying something hit this policy, this security intelligence policy, but it still was allowed through. It'll go through the regular access control, the regular rules after that. but it's something to be aware of. You will get an alert for this in your logs, and it's good for testing, but if you're going to be deploying this at first like this, you definitely want to make sure that you eventually change these to block or remove these feeds from your blacklist, because there's no point in having it there just to monitor unless, I mean, it's not really taking action. It would be better to long-term to create some kind of hooks in there. And as you can see here, here's the URL policies down here. And again, these are feeds from the Cisco Talos again. And I have all of them set to monitor only. Now I can go ahead and block them, or I can create a custom list, add it in here, and then block it as well. So let me go ahead and create a custom object for you guys, and I'll show you this really quickly. So new network list. Let's see, Notepad, 10.95. This is a host on my outside network, so I'm just going to go ahead and blacklist this one. Blacklist. This is going to, of course, be a list. So this is something, blacklist, VPN client, VPN computer. So I know what to do with it later. Let's see if I put that in documents. There we go. So upload, save, and let's go ahead and add that one to my blacklist. And I'm going to block that one. So yeah, this one's original. By default, also be very aware that by default it is block. So you have to right click and say monitor only if you want to monitor. Now, this is a computer of mine that's sitting behind the firewall. So let's go ahead and test this out and try to go to that computer that IP address that's blocked now. So HTTP 10.95.51.141. Let's see if anything goes. Oh, actually, you know what? I haven't saved this yet. All right, I got to save my policy and push it out to the firewall before it's going to take action. So let's do this. It'll take about a minute to do so, and once that happens, I shouldn't be able to reach out to that URL. It's going to drop it. So while that's deploying, because it does take a couple minutes there, or about a minute, some of the different things I'm going to kind of show you is, so you can kind of, I mentioned before that you do have that blacklist and the whitelist that you can manually add things to. So you can go to the Context Explorer, for example, and scroll down to an IP address, and by clicking on it, you're able to determine, okay, I'm going to add this to the whitelist or the blacklist. I'll give it a moment. I'm actually pulling up everything for last week. So if you can see here, I click on this IP address, traffic by source IP. I can say blacklist now, whitelist now. I can also drill into analysis and add a filter to get more information on that specifically. Another thing you could also do is you can look at the connection events, and in those connection events, you can add something to a whitelist or blacklist to, whether it's the actual IP address or the URL itself. So right-click this, blacklist IP now, whitelist IP now. Same with the responder IP. Let's find a URL really quickly. All right, so here's a URL over here. So I can actually whitelist or blacklist the URL or the domain itself. So kind of a neat way to get very granular if you want to manually add stuff. I don't typically see, I would suggest updating a list or a feed rather than manually going through and adding stuff to your blacklist. Just a lot neater that way, and it's easy to update and delete things off of a feed. Even if it's a SharePoint site, it's really easy. You can kind of do it that way. Let's see. Yeah, so next thing I kind of want to go through. Let's see if that policy's been deployed first. It's almost there. Once this is deployed, we're going to go ahead and try to reach out to that IP address again, see it dropped, and look at the actual logs in Firepower and see how that looks. So we're just going to give it a minute. It's kind of on its final stretch. It's redeploying that policy to that little ASA right there sitting at the edge of my network. I believe while we're waiting on that, this is a good time to kind of stop and take questions. Anyone have any questions on what I'm showing so far? Just type it into the chat. You guys are pretty easy so far. All right, give me a moment. It's yes. Somebody asked, how does Firepower deal with SSL traffic? How does it know if file is downloaded so it can run a hash for further analysis? Actually, I'm going to ask you to table that question because later on in this session, I am going to actually go into SSL decryption and AMP. So that's something that's going to be answered later, and I don't want us to get out of order or sidetracked. So we'll definitely dig into that deeper. So let's see if that's, okay, that's been deployed. Let's try this again. See if, all right, we're waiting. Now it's not connecting. So let's go over here to my security intelligence events for the last hour. Let's go ahead and say last hour and apply. See if it pops up yet. Oh, that actually, there we go. So as you can see here, the security intelligence event, it sees that IP address was to blacklist it. So in this case, the action was to, should say block. Yeah, reason IP block, action block. So good to know. I can kind of drill into that further, but that's the only security intelligence event we have right now. Next thing I'm going to go through is the object management. Now, you can build a lot of your policies, by scratch in the access control policy, but the reality is that a lot of your objects that you'll be using, like your subnets, maybe your interface groups, a lot of them are going to be reused in different policies or maybe different policy group, rules. And some of them you do actually have to build here. So, I kind of wanted to go through the object management portion of Firepower and kind of explain to you some of the different things you configure here. Now, the most basic one, which we went through last time, is the network object. So this can not only, any of these things you can kind of create, oh, hold on. I'm sorry, somebody asked a question. For the blacklist, does it block internal hosts as well if we wanted to block a host from getting out to the internet? Yeah, if you wanted to block a certain host, you could. There probably are better ways of doing that than just specifically blocking one or two hosts. But if there's a corner case where there's just one single machine, not a subnet or anything like that, or like a separate zone you're putting them in, yes, you can absolutely block a single host from getting out to the internet. It's not typically something I would do based on just blacklist. I would probably do something like I would probably create like a separate access control rule so it's a little bit more organized, and I can see that when I'm looking down my access control rule. So you don't necessarily have to add it to security intelligence. There's just cleaner ways of doing it, and it kind of looks more logical in the sense of looking like at an ACL, but except for your policy. So I'm going to hold questions till we get through this section. So object management, some of the different things. Network, you can group, do one single subnet here and just have that reused, or you can do groups, subnets together, like say all your internal hosts or subnets. Maybe you want to create a group of subnets for your DMZ. So maybe you have multiple sites and each site has a DMZ, but your DMZs at every single site are going to have the same policy. So it's easier to create a network object with all of the actual subnets in there and then create one access control rule for that in your policy than it is to create 5 different lines, each with like the same different networks, or just trying to add them a la carte one by one. So this is kind of something that's useful in your policies. And you also, later when I get to variable sets, that's something you also can create for your variable sets as well. Just get to that in a few minutes. Another thing you could do is ports. So you can add custom ports for maybe applications that your company uses. If you wanted to create kind of a policy based on that port it's reaching out to, or maybe it's an internal port, maybe you have a custom application in your company and you're using firepower as an IPS, you would that custom application uses port 31337. TCP port 31337. So what you can do is you can add that port in here, or maybe a group of ports, and that's something you can call out in your access control rules. And instead of sitting there and just trying to add, making it overcomplicated, you create it based on those port groups, and their originating network is in your inside network, or it's something going out to a certain IP address on the internet if it's a custom cloud application, for example. So this gets very useful if you wanted to define something like this in your network or in your policy. A lot of these things here, just think that they're something you can be. In most cases, they're ingredients you can add to the recipe that is your access control policy. And it just makes it easier to group these together and define them ahead of time, give them a name that makes sense to you, than trying to add them manually one by one when you're actually in your access control policy. It makes it easier. You can define them by names that make more sense. For example, your interface groups. You may have, for example, you want to create an interface group that you're going to apply the same policy for across your entire network, say, for example, WAN interface group. So you can take, define an interface group, call it WAN interface group, and define the WAN interface for all of the ASAs or firepower appliances in your entire network. You can do that here, and then you reuse this object in your policy later on. See, the application filter. Now, this is if you wanted to create kind of, so what you can do in your access control rules is you can define different applications you want to detect or create policies on. Those aren't, and I'm not talking just about, what port it's using. I'm talking about like the app, maybe it's like a chat client inside of the browser, a Hangouts would be, Google Hangouts would be an example. So what you can do is if there's a certain set of applications you want to define and create a policy for, instead of defining them one by one in your policy, in your access control policy, you can create so it's something like business applications. And let's say my company uses, let's see if Hangouts shows up. So my company uses Google Hangouts and Jabber, Cisco Jabber. I also use it for audio and video. And what's another good chat client? I'm trying to think of Slack. Let's see if Slack shows up. Yes. So these are my business chat applications. So I can create this list of applications in here that it's going to look for and detect, and in my access control policy, I can define a policy based on this group of applications instead of calling them out one by one. It's a lot easier also if you have multiple rules based on this to go through. If you decide to stop using Jabber, for example, instead of having to go through 5 different rules or like multiple access control policies, you just remove it from this group. and all of your other access control policies and rules are updated. You can also do VLAN tags. You can add a single VLAN tag object or groups of them. So maybe you're going to create a policy for your guest networks out there, or your guest subnets, and you know that in every network you have VLAN 100, 110, and 120 are ones that guests use or vendors use. So you can create a VLAN object group where you're adding those specific VLANs in there, and you can create that policy based on that in Firepower. Another thing that you can do is you can add a custom URL or group of URLs. One thing to be careful of in here is when you're doing this, you have to be very specific with the URL, or you're going to have a problem where it blocks everything with the same string of characters. So I'm going to go ahead and do routergods.com. So later we're going to block routergods.com from being accessed. Sorry, Humphrey, wherever you are. Okay, let's see. Now the variable set, we did configure this the last time I was here, and the variable set, default variable set, is just it's kind of the fill in the blanks for what a snore policy looks like. So if you look at a raw snore policy, the raw snore policy, when you look at it, it's kind of got these variables and how it fills in the blanks. So let's see if I can pull up a raw one for you to see how that looks. Let's see. Okay. So if you see here, like the source and destination IP addresses, that's a variable for home net, external net. You got to ask yourself, well, like, what the hell are these things? Well, those are filled, those blanks are filled in by your variable set, and the default one is in here. But you can create multiple variable sets, and the reason you might want to do that is your home net might look different for your DMZ, and if you're wanting to create a policy where the snort rules are configured differently based on maybe your network speaking, for DMZ, maybe I'll go ahead and create an object for DMZ. So my DMZ for my network is 192.162.1.0/24, and I want that to be the home network for the variable, the snort rules for that specific rule that I'll create, or access control policy I'll create for DMZ. So going back into the variable set, I'm going to go ahead and add a variable set, and it duplicated just the way it was for this one, but in this case I'm going to say it's a DMZ variable set. And I'm going to change my home network to not be this internal network, but I'm going to have it be that DMZ network I just created before. So I'm going to include that as the included network. And later on, when we kind of play around with some of these access control policies, you'll see how I might use some, put that into play. We kind of went over the security intelligence, obviously. Geolocation is kind of is kind of an easy one. That's if you wanted to add some countries to be defined in here, you go ahead and add that. Sinkhole is something we'll brush on deeper into the DNS policy, but you can add a sinkhole server, and that's something that you can use for kind of like a honeypot DNS server. And you can kind of define what type it's going to be, and the IPv6 or v4 address, and the name of it. So sinkhole demo test. And the IP address I'm going to do for that is going to be one that doesn't exist in my network. So let's go ahead and say 155. And this is going to be command and control. So that's going to be my I don't need to, crap. Forgot that I have to actually put a IPv6 address. Crap. IPv6. Let's go ahead and do 281. See if that accepts that. Okay, cool. So we'll use that later in our DNS policy. Another thing we can do is we can create a file list. That can be a clean list or a custom detection list. Now we'll get into AMP a bit later as well, but if you wanted to, let's say there's something that's not detected by AMP, or it's not even a piece of malware, but there's a file you don't want being downloaded or executed or seen traveling across firepower, you can actually add that file in here, and all you have to do is you can either add the SHA-256, you can add a list of them, or you can have it calculated by uploading the file. So let's go ahead and add the blacklist. And this will calculate it for me really quick. Okay, so this is going to be my custom detection list. So save. And that's added in there. So if that file traverses firepower, it's going to create a detection and potentially block it as well. Cipher suite list is probably a little. So the distinguished name list, this is, we're not going to jump too far into this, but this is basically so we can create a list for public key certificates subject, like for issuer. You can basically define like a CN name for certificates that you would trust or you would use in a policy. So this is where you would add those distinguished names, and it could definitely be factored into your policy later. So it's good to know that you can either define an individual one here or an object. The PKI, this can be used for ICE integration. This can also be used for when you're doing your SSL Decrypt. It's important to know where to add these certificates and where to generate. You can also, if you're doing SSL Decrypt, where you're basically acting as a man in the middle, this is also where you would create your CA certificate for firepower, the self-signed one. This is where you would create it if you wanted to do that and you didn't have a publicly signed certificate for that use. SLA monitor, for anyone routing and switching, this is kind of self-explanatory. It's you can create, edit, and copy SLA monitor objects here. It defines a connectivity policy to a monitored address and tracks the availability of a route to the address. It's basically periodically checked for availability by sending ICMP echo requests and waiting for the response. If it times out, it'll remove that route from the routing table. So you can configure that here and set it up. So a lot of stuff down here is starting to get into the routing and switching territory, or I'm sorry, routing and VPN territory. So prefix list, that's gonna, for any of you lovely BGP lovers, that's pretty self-explanatory. So you can add prefixes list. Oh, I'm sorry. Sorry, that's I was thinking ASPath. Prefix list, so like IP prefix list for potentially using for route maps or for routing and routing later. So you can add that here. You can create route maps as well. So that's if you're using like using this for routing. Right now I'm just using the ASA with firepower module, so it's not really going to be able to do any of that extra stuff. You can do the create a standard or extended access list. ASPath prepend for, of course, BGP, so you can start adding stuff in there. Also, community lists, again, for BGP. You can go ahead and start adding stuff. And your policy list, again, BGP. So as you can see, you can kind of start adding that in there. And VPN, which I'm not going to jump too into, but here's where you can kind of create some of these ICV2 and V1 policies. It's not that hard to do, but I can't really test this out for you guys, so I kind of have to brush through this. I'm going to stop for questions because this is probably a lot. I just kind of wanted to go through, the objects, because there's a lot you can configure and set up here before you start configuring your policy. Any questions about object management so far? Okay, I think we're good so far. Yes. Oh, what is the routing item about? So firepower appliances like that are in the firepower threat defense. That's basically the unified image where you don't have a separate software image in ASA. It basically takes over the iOS for ASA. It doesn't exist anymore, and it's doing all those routing and ASA functions. So configuring something like that, you can create kind of like your IKE policies for VPN, your BGP policies to basically configure it for BGP, and that's kind of like where you can define some of those things you'd be using for that. If I wanted to actually go over to the device, I could create that here, but none of these devices are in firepower threat defense. Doesn't have that image loaded up, so I can't do it. But if I could basically just go in here and configure routing, switching, OSPF, everything. So somebody said, I don't usually route on an ASA, I route on a router connected ASA. Yeah, fair enough, but some people do. There's not going to be a time where probably Cisco stops making the ability to route on an ASA. So it's there, and that's kind of adding those features to be able to do it here. So the next thing I kind of wanted to go over was application detection. So Firepower utilizes an open source application-focused detection language called Open App ID. Hold on a second. Where do you add SSL certificate to replace the self-signed certificate, SSL certificate? Right here under object management, under PKI. This is where you can start adding internal certificate CAs and internal certificates. Let's see. Internal CA groups, cert groups. So you can configure a lot of this stuff here. You add them here, and then you start configuring them in your policy. So just bear in mind, anything you add here isn't taking in, there's no action taken on it until you can add it to a policy elsewhere. But this is where you upload certificates. That's under PKI. So going back into application detection, so how, I'm not talking about just discovering what ports or, the traffic is going out. It's to actually look at the application, that, what's going on inside the packet, what browser, a lot of things that are looked at. Firepower utilizes something called Open App ID, and that's basically open source. So it allows users that utilize this to create, share, and implement new applications. It's kind of the same way Snort is open to intrusion rules. Open App ID is open source application detection. So there's three types of applications that the Firepower system detects. Application protocols, and that's typically what you think of, like HTTP, SSH. You look at that port, really, it represents that communication between hosts. The clients, such as the web browser, the email client, there's a lot, which represents the software running the host. And then there's the web applications, such as like maybe the MPEG video that's embedded, or Facebook, like chat applications, that's actually embedded in there. There's two sources of application detectors inside of Firepower. It's basically the system-provided detectors, which detect web applications, clients, applications, and protocols. And then there's custom ones, which you can create and you can add on there. So if you have something that is a custom application, or you wanted to kind of drill into it deeper, you can actually create that here. Now, I don't see a lot of people doing it typically, but you do have the option to do it by, so under Policies, Application Detectors, you can click Create Custom Policy, or Custom Detector, and we're going to call this routergods. This is routergods app. This is the routergods application, if I can spell it right. And we're going to go ahead and define some things here. So routergods app. RGA. We can define what the business relevance of this is. So we're going to say it's very high, very important, router gods. The risk is very low. Let's go ahead and put the category as peer-to-peer. Is the application detection based on a hash of the application? No. It's based on a number of detectors that actually look inside the packet. Hold on a sec. Let me get through this. We're going to have breaks in between, but I can't stop and answer questions. It's going to throw the whole thing off. There's typically a lot of people attending this, so I want to make sure we stop in between each kind of section we're doing, and I'll answer questions there. So I'm going to say that this is a, you know, let's say it's donkey. So we're going to go there, add just the application editor, giving it some different things, and see routergods. There we go. That's the one I just created. Now, it hasn't created the actual application detector yet, so we can define in here kind of some of the detected patterns. So it could be, you know, the protocol could be TCP, UDP, HTTP, SSL, SIP, RTMP. We can, you know, define it based on, you know, ASCII or hex pattern that we see, kind of the offset on, you know, what the offset is. It's the location in a packet in bytes from the beginning of the packet payload and where the system should be, you know, searching for the pattern. Now, that's not a requirement, but it's nice to look. The port of the traffic, you know, the port of traffic the detector should inspect, and the direction. Is it a client? Is it a server? You can kind of define those things here, which I'm going to just say, you know, routergods is the pattern. You can also, if you do a packet capture of how that application behaves, you can actually upload this here and add that as a way to, you know, increase fidelity of your custom application. Now, this is kind of the recommended way to do this, and adding those packet captures, so you know, my firepower system not only knows these detection patterns that kind of define this routergod application, but also being able to look at what the packet capture looks like. It's just going to increase your fidelity a lot more. So once you save this, save as new. I guess I've created that before. routergods app 1. I've created basically at this point a new application, which probably is going to have some pretty crappy fidelity because all I did was define routergods and, you know, from the client source. But you do have a lot of flexibility to kind of change this around and look at the actual, and you can also change it, like, you know, what IP address it's going to, and a lot of things you can expand into this, but on a basic level, it's going to give you quite a bit of information and selection. You typically can use just the defaults, but the case I'd see this at is if there's a custom application your company typically uses, and you wanted to go ahead and define some custom snort rules for it, or just have it detected. That's going to be one of those things, corner cases, where you're going to create a custom detector. So Matt, is application detection, I'm stopping at this point for the application detector. You asked, is the application detector based on hash of the application? No, in this case, as you can see, it was actually based on, you know, a behavior, packet captures, a bunch of things you can kind of configure here to make it your own application. Obviously, if it was like a file being downloaded or something like that, you can create a file object, but in this case, we're looking at just the transferring packets that are going across your network. You can add multiple different things you can. So, like for example, HTTP, you can define the URL it's going to, the user agent, the content agent, add that pattern in there. And I forgot to mention this. You basically change you change this protocol. It's going to give you different options that are relative to that protocol. Now, this is supposed to be the the intermediary firepower class. So obviously, this is kind of more than what the average network engineer is going to be doing on this thing, but it's good to know it's there. Any other questions besides BATS for custom application detection? routergods app. Actually, I think I'm going to tweak this a little bit. Let me go ahead and change it so it's the routergods app is going based on the routergods URL too. So that way, it's going to actually see my custom detection. So HTTP type URL pattern is routergods.com. So we'll play around with this policy a little bit, and we'll first create a custom app policy, and then we'll also block routergods because I created a custom URL. So then since there's no other questions, hold on, I'm going to drink some Coke real quick. Okay, awesome. Whoa, somebody unmuted. There you go. Muted. Sorry, if anyone has any questions, do it in the chat. It's easier to manage that way, or else we're going to have a lot of noise in the background. But if you have any questions, I saw someone unmuted, so I'm going to give you a chance to type that in real quick. If you have a question. Custom application detector question on F5 ASM. It detects Linux commands as signatures. This fire. I'm sure you could probably enter strings that do it, but I wouldn't know how to do it just based off of Linux commands, to be honest. Like a keyworks link and route. Honestly, I have no idea how F5 does it, but you can do ASCII, like TCP, UDP. It looks at the words in there. I would think you could define it as well, but there's a lot of flexibility in here, different things you can do. So TCP, look for like ASCII patterns, or hex, same with UDP, client server. I would assume so, but it's basically going to look at the packet and look for certain things that are being sent across, and you can define what those are to kind of call out your application. But as far as Linux-specific commands, I don't know how F5 does it, but I would assume that if it's inspecting the packages like this, it's something you can kind of call out with ASCII characters, like words and stuff, like you're saying. Okay, so any other questions? No problem, Raymond. Yeah, I haven't worked on F5 for years, so I have no idea how they do anything anymore. I just did basic load balancing with them. So also, after you create your application, important thing is to enable it, because by default it is disabled. So all you have to do is turn it on there. It takes a minute because it does actually update it on there. But after it does, it's set it and forget it. So give me a moment. I'll let that finish. The next thing I'm going to kind of go through really quick is SSL decryption policies. So I'll just switch to the whiteboard briefly, and we'll talk about that. Now, the SSL decryption is not available on virtual NG IPSs. So if you have a VM that's running your IPS, you're not going to be able to do SSL decrypt. And someone asked, if Firepower can inspect the traffic that's SSL decrypted. By default, if it's encrypted, no. your SSL policy determines how your system does handle that encrypted traffic. So the SSL inspection feature allows you to block encrypted traffic without inspecting it based on a number of factors. You can inspect it, decrypt it. You can decrypt certain types of traffic. It can also drop unencryptable traffic, and there's certain hashes and things like PFS that are extremely hard to decrypt. Now, if you're running an ASA with firepower, my recommendation is not to be using your firepower, your ASA for decryption. It's not hardware offloaded, and it's quite taxing on your system, to be honest. But also, there's legal things you have to think about when it comes to SSL decryption. So all it takes is a well-placed lawsuit if you're, decrypting everything and your CEO logs into his bank. There's a certain legal liability you don't want to be a part of if that happens. It's one of those things, if you are going to be implementing SSL decryption in any point of your network, you have to check with your legal team. If not, you're opening the back door to something that's potentially disastrous. And someone also sent me a message saying also compliance concerns like PCI. Definitely. SSL is a scary thing. It's something you can send, you can send stuff out to, like, credit cards, social security numbers, a number of things. And, there are extremes where you could decrypt everything. But the problem is when you do that, you open yourself up to liabilities as well. So it's something to be aware of. You are able to do an SSL decryption policy on here, and there are going to be certain types of traffic that the encryption can't be decrypted. Maybe it's malformed. Maybe the actual SSL handshake is damaged somehow. Maybe the server's malfunctioning. Certain things may not be able to be decrypted because of that. And if that's the case, you can make it as part of your SSL policy to potentially either drop it or just allow it through. It depends on how strict your network is. Now, the typical use cases for SSL decryption is you're going to have this is called resign. So resign, and that's basically where you've got your user computer sitting on your LAN somewhere, and they're sending traffic out to the internet, and it's going through your ASA, and your ASA, and then out to global internet, where the URL. So as that traffic's being sent through, the ASA basically does two SSL sessions, one with the URL there and one with the user, and it's at that point decrypting and then encrypting, sending it back out. And to anyone who's knows hacking, that's a man-in-the-middle attack. This situation I would use very, very, very with caution, because obviously there's going to be some legal issues with it. And I know that from a network engineer standpoint, a lot of us are just like, well, the hell with it, let's just decrypt everything. Yeah, that could get you in a lot of trouble later on, especially if your C-level executives start noticing that their banks are, they can't get to their banks or accounts, or that the IT is potentially looking at their banking statements. So again, exercise caution. The second thing is where you have a known key. So a good use case for this is you've got your ASA, and you've got out on the internet your customers or users, whatever. And they're trying to reach this web server sitting in your DMZ. So as they're sending the traffic there, the ASA has a copy of that certificate that should be on the so it's got a copy of the cert, and it'll negotiate that whole SSL session with the customer or your users, and at that point it will send the traffic to over to the web host. Now this is actually something I would potentially use the ASA for. It wants to decrypt the traffic and look at who's sending what to my public web servers. That actually would make a lot of sense for me. Like this resign, I definitely wouldn't recommend doing. This is known certificate. So when we create a SSL policy or a rule in the SSL policy, there's a couple things I'm just going to go through. There's the components to this SSL rule that we create. The first one is you got to create this. There's a state. So let's go ahead and look at what the SSL rule looks like. SSL rule. The first thing is the state. By default, it's enabled, but you can enable, disable it. And then the position. So just like your access control policy, where in the policy, it's, you can rearrange your rules. Now you don't have to necessarily configure it right here when you're creating the rule, but you can drag and drop just like in your access control policy. The conditions, which basically say what traffic is this rule going to handle. So it can be what is the traffic I care about. And then the action. So there's a couple different actions you can do. So the first one is decrypt with resign, and that was the man-in-the-middle attack I was telling you guys about before. There's decrypt with known key. That's where you would have maybe your DMZ server or something that people are going to be using on the internet. You have your do not decrypt, because maybe you don't want to decrypt banking customers. Decrypt. You have block, which this is a pretty inefficient way of doing it, to be honest. If you do block, it's basically going to drop the packets, so that end host is just going to constantly be reaching out, trying to reconnect until it times out. So it's kind of a waste in that sense. But if you're going to be doing block, my suggestion is to do block with reset, because it'll immediately reset that connection, and that host will stop trying to reach out. It's just wasting less bandwidth. And then there's just monitor, where you're just logging it. So what I'm going to go ahead and do is kind of walk through creation of your SSL policy. So in Firepower 6.0 and later, you would just go to Policies, Access Control, and SSL. A second to, and I've already created one, but let's go ahead and create a new one. So this will be routergods policy, and this is the policy for this class. So after this is created, let's go ahead and, yay, Internet Explorer, or I should say Firefox. So here we go. And it looks a lot like the access control policy. And now, remember, nothing is in effect here until we apply this to an access control policy. So right now, we're just configuring the components for it so I can add it into an access control policy. The access control policy is always what's going to be applied, when we create our objects or anything else. They're not actually doing anything until they're added to that access control policy at the end. So the first thing I'm going to do is I'm going to go ahead and add a rule. So do not decrypt banking. Now, this would be an important one if you like to keep your job and your CIO is going to be checking his bank every day. I definitely would be trying to put this into place. So let's go ahead and take a look at the category. Let's see. Is it listed under finance, or, yeah, financial services would be a good one. Let's see if banking pulls anything up. No. So in this case, my first rule is going to be don't decrypt banking. I really don't want to lose my job. And the source, you don't have to define a source network, but for the sake of doing so, I'm going to go ahead and just say add to the source. And of course, I like to log everything. What's a good one for us to add a decryption rule to? Let's go ahead and say we're going to go ahead and decrypt something non-conspicuous. So we're going to go ahead and decrypt design with, I haven't created a CA, but if I was going to decrypt, I would have to actually go in and generate a self-signed certificate unless I wanted to use a public one in my object. But I don't have one right now, so let's just, for shits and giggles, we'll go ahead and pretend like I did. I would want to go ahead and add, I could do a category, if there's a specific certificate it sees being passed, it'll go ahead and decrypt that. If I just want to look at cipher suites, I can go ahead and the ones that maybe aren't going to be that I deem as insecure, I'm going to go ahead and take a look and make sure there's nothing going on inside those packets. So I can create a policy like that here, and just create those based on rules. And I can say I'm going to go ahead and decrypt anything to do with maybe adult and pornography, or maybe drugs, something illegal like drugs. I don't want my users to be able to, I don't want, if they're going to those kind of sites, I want to know what they're doing. Maybe it's a potential HR violation. That's where I would maybe create a rule here. And if I had a DMZ server, like I said before about the known key, so I can do DMZ web server, and this would be a decrypt with known key, and then I'd select the certificate that I uploaded, so a custom certificate, and then I could specify that hey, it's going to be any network coming from source going to a specific IP address or set of IP addresses. I can go ahead and define what it's going to be decrypting, and I can specify ports. I can get pretty granular with this, the zones. Maybe if I created a outside to DMZ, I can just decrypt everything going from those zones instead. So that would be a rule that I would potentially create and put into production right there. And with this known key, I'm basically I already have the key, so it's less work for me, and I'm just decrypting as it's passing through me. So after you're done creating this SSL rule, to add that into your access control policy, we go back up here to Policies, Access Control, and right here, I'm going to go ahead and add that right into the SSL policy. So if I wanted to add an SSL policy, I just drop it right in here, and that's going to be the SSL policy for this access control policy. Push that out to the clients, and that's what would be used for this entire access control policy. One thing also I would specify is in the SSL policy, you can define what you're going to do with unencryptable traffic, because in most cases I would assume you would want to let this go through, but if you're in a high security environment, you can go ahead and say block with reset if it's depending on the reason why it wasn't able to be decrypted. If it's like handshake errors or unsupported cipher suites, this you might want to still let it through because you never know what it is. But handshake errors or decryption errors, you might want to go ahead and block that from being let through your environment. So this is, in that SSL policy that we just created, we could define what we wanted to do with these. So just a heads up there. And any questions so far? Man, you guys are easy. I'll let you guys type if anyone has anything to type. Okay, I'm just going to assume we are good. The next thing I wanted to kind of talk about is your DNS policy, and it's a lot like your it's tied in there with your security intelligence, obviously, because there's the global whitelist, blacklist, and there's the feeds that you can add in here to the blacklist. But there's also a couple things that you can also do that are kind of a little more interesting. So when you create rules in this policy, you know, there's different actions you can take. So whitelisting, pretty self-explanatory. There's you can just monitor it where you get a log of it. You can decide to drop it, which just causes the host to try again until it times out. Again, not probably the best way of doing it, but it'll keep sending that over and over and over and over again. Or you can do domain not found, where it'll just Firepower will send back a response to that DNS request saying, sorry, domain not found, and it's that host stops trying to reach out to DNS for it. And another interesting thing is sinkhole, which this is pretty awesome. It's probably for more of the complicated security folks that like to run some forensics or kind of see how that malware is behaving. So it's a way of following the host by picking a server or fake DNS server, and instead of replying with the requested domain, so if that malware is reaching out to a known bad domain, what it will do is it'll respond with the sinkhole that you define, which in this case I created earlier in my object group the sinkhole demo test. So it's going to reply with that IP address to whatever's reaching out, and that traffic's going to be rediverted there. So if you're running, if you have like a packet capture on that IP address or a honeypot, it's a great place to send stuff for some advanced forensics or just to see how that malware behaves. By default, when you create a DNS policy, there's only 2 rules in here. There's global whitelist and blacklist. You can create these custom rules, as I said, which I did here, and the policy components when you create these fairly easy. It's basically name and description, the action it's going to take, which we kind of went through that already, and the conditions, which are you can base it on zones, networks, VLAN tags, or DNS lists and feeds. You can very, very easy stuff, but good to know. It's kind of the way that malware is written these days. It's kind of good to define that in a policy somewhere. And also, when you start getting things pinging back at you on that honeypot server, even though you're not necessarily checking the logs on Firepower every day or checking alerts necessarily, you could also be gathering important forensic information off that honeypot, and it's going to give you a more full picture than just blocking it necessarily. So kind of a cool thing to take a look at. So I'm going to just test before we created our policy where we created the URL for routergods. I kind of wanted to test that out and show that to you just for fun. So give me a second. Let's go ahead and create a rule where we're going to block or do a block for routergods. And I kind of touched on how to create a URL rule the last time we were having this meetings, but we're going to go ahead and say routergods redirect, and we're going to go ahead and do a interactive block. And the interactive block is where you get the IP, the splash page in front, and it basically says, do you want to go ahead and proceed? So the URL is going to be that rule I created before, and we're going to go ahead and put this as right above every other rule. So it's going to be 1 and router. That creates it in the URLs. oh, here, my bad. So add to rule. And so interactive block with reset. We're going to also, of course, make sure that this is logged. And this is above all my other rules because it does operate in order. Another thing you can do is, so that interactive block response page is going to give us a system provided one. We can customize that pretty easily. So you're attempting blah, blah, blah. By clicking on this page, you are accepting that you are property of routergods. There we go. Save. I like that. So let's go ahead and test this guy out. Let's let that deploy for a minute, and then we'll try to reach out to routergods. So before moving on from DNS policy, any questions as of yet about DNS policy or about anything we've done so far? I don't want to lose anybody. I want to make sure that we're doing regularly scheduled questions. Nothing so far. It's almost done. Okay, so the last thing we're going to cover today is AMP. So AMP was something we covered last time briefly, and I had mentioned some of the different things. The reason why I like AMP more than something like antivirus is something to be aware of is malware is kind of isn't just is kind of a blanket umbrella term for a lot of different kinds of software out there. So what malware could be is anywhere from viruses, worms, Trojans, potentially unwanted applications, rootkits, exploit kits. And some of the typical things that you see malware do is, it'll register with a CNC server out there on the internet, which, again, importance of using security intelligence and DNS feeds is you can kind of block it from reaching out there, but if it's unknown or if it's just a new domain, you might miss it. But so it's many layers of security, include AMP is just one of them. So you'll see that you can potentially see your malware reaching out to do that. CryptoLocker is another popular one where it encrypts the whole hard drive to prevent you from being able to access your software, and you have to pay in Bitcoins. Now, before it completely deletes that private key and finishes the encryption, it has to reach out and give that private key to the server somewhere on the internet. Now, if that thing is blocked from ever reaching out to the internet, it never finishes the encryption. So yes, you still have that CryptoLocker on your computer. Yes, the second it's able to get through to the internet, like it may be blocked behind your firewall because it's using something that firepower has seen before. The second that user disconnects that laptop, takes it home, and connects outside of there, they still might get encrypted the second they land at home. But that's something that a typical behavior of malware. It could stay quiet and just turn that infected host into a zombie for a future DDoS attack. Funny as it is, it may actually mine Bitcoins in the background, steal your passwords, start a DDoS attack automatically. Some of these pieces of malware are very tricky, where they wait for a certain amount of time. They're like kind of a time bomb, or they check to make sure that the MAC address for this, wherever it's being run on is not a VMware MAC address, so it knows it's not inside of a sandbox. And it may wait for some kind of user interaction. So since malware has become more of an industry, because it's no longer a bunch of kids just getting together and writing crap on war sites as much anymore, there's you look at crypto locker, you look at some of, stealing medical records. There's a huge industry and a lot of money to be made. Sometimes it's a political statement where you just want, where that hacker is looking to destroy a company. I mean, look at Sony Pictures, for example. Now, if you believe that that it was perpetrated by North Korea, that's, political and terroristic at the same time, and that resulted in a CEO leaving the company. It was, and a lot of the people who work there, and even spouses, because their medical records were tied to their name and their insurance, I mean, have to constantly check their credit now because all their information is sitting out there on a torrent site somewhere or being shared via torrents. By the way, this policy is just finished deploying, so I'm going to go ahead and test out trying to go to routergods.com really quickly. So routergods.com. Let's see if I get that custom page. All right, it didn't give me the custom one. I must have done something not saved correctly, but it does give me the access is denied, and it allows me to click continue. So if I click continue, it should allow me to go through. routergods, hooray! Okay, so I've been very easily amused, but yeah, that would be a interactive block. If I wanted to completely block it, which isn't as much fun because I'm not able to. So by clicking here, you're accepting that you're property of routergods. Don't know why that didn't go through, but I'll check later. But as you can see here, there's a couple different things you can do if you just want to give a warning to your users. Also, my rule here is to block social media. So this is just an actual block with reset. So if I go to MySpace now, it's not going to even let me through. It's just blocked, like done. MySpace is done. I don't have to deploy that because I had that existing policy, out there. The only thing I added was routergods redirect, and that was already there, or that was already deployed while I was sitting here talking about AMP with you guys. So going back to AMP. There's two things the file and malware policy does here on Firepower. The first thing is that it does file discovery, and it looks into the file itself, not the extension, by doing file detection, and it's looking at the packet and how the actual file is constructed. Because anyone could rewrite, change the extension on a file and potentially get through application blockers if that was all your file blockers. If that was all it was looking for. If it was looking for an EXE and you renamed it to PDF, then your security is kind of crap. So file discovery on Firepower actually looks at the entire file before defining it what it is and either allowing it through or blocking it. The second thing it does is it does an anti-malware component. There's three dispositions that you can get for this file component, which is malware, which is very bad, clean, which means that it's seen that file before and it's based on other users and other things in the Talos cloud, that file is clean and there's nothing for the time being. It should be just sent through. And then there's neutral or unknown, and how neutral and unknown are, as you can see here, I've just got 3 files and they're all clean. How neutral and unknown is treated is dependent upon how you write your policy. Now, you can sandbox it where it sends that file up to the Talos cloud, and the Talos cloud, send it to the threat grid cloud, and it's going to sandbox it and see how it works. Now, sandboxing a 0-day anything is going to take about 7 to 10 minutes. So that file may get through in the meantime, but you will get that retrospective analysis, and future versions of that file are blocked, and you can technically create a policy where unknown is blocked, but you don't want to do that because you never know how many files like that you'll get. So just be aware. So let me go ahead and pull up the whiteboard real quick. So when a Firepower's, let's say you've got your Firepower appliance right here. Why is this thing not, okay, give me a second. Okay. So you got your ASA here, or firepower appliance, and then your user here downloading a file, and great scary internet. So what happens when this is downloading is that every single bit is collected, and the ASA lets it come through to this user's computer, every single bit, because you can't determine if it's malware if you're only looking at packet by packet. And as somebody asked if the threat grid, you need a threat grid subscription? No. If you have an AMP license for your firepower, you can actually use the sandboxing feature. It will send it to the threat grid cloud. You don't get to send any file you want, but if it's passing through your firewall and it's an unknown, yeah, you can send it up there. It's not a problem. It's going to automatically do that if you define that in your policy. But now, again, let's try to make sure that the questions are kind of at the end. So as this file is downloading, it gets to the very last bit, and it holds that bit, and it takes that, hashes it to a SHA-256 hash, and sends it up to the AMP cloud. SHA-256 gets sent there. Now, at that point, it'll wait a certain amount of time to, and AMP will check that SHA against one-to-one signature here, which will say, have I seen that before? If not, I'm going to go ahead and do some additional analysis of it. Now, if it's an executable file, it may send the metadata along with it, which is called Spiro. Just a feature called Spiro, but it's only for the executable files. It's kind of sending all the metadata that would be. Questions at the end, if you don't mind. It gets a little distracting. I'm trying to get through the whole thing instead of getting sidetracked. So the one-to-one signature hash matching, which it can go ahead and do that, but if you type anything differently, or if that file is renamed, or anything's changed in that file, that may potentially not, skew it's not the renaming, but anything inside the file changing. If it's a doc file or a PDF file, changing that around could, make this a little ineffective. The metadata for Spiro, that's, it's just kind of some additional contextual information. And then there's something called ethos, which is fuzzy fingerprinting. Kind of funny to call it that, but what it can do is, it can tell how the hash is, where that file originally derived originally. So, like for example, polymorphic malware may change the file just slightly, so it doesn't get detected by local antivirus or malware. What ethos will do is, typically when these polymorphic malware changes it, they don't change it that much. So even if the SHA is completely different, mathematically it can figure out if it's like 90% similar to maybe a known malware family, and it'll give it kind of like some demerit points as it's trying to assess this SHA. So it's not necessarily going to say it's going to be just malware based on this, but if it's 99% similar and there's just a few bits changed, it's going to that's probably going to send it into defined as malware. The good thing about this is, these hashes and signatures are always stored in this Talos cloud, which, give me a sec, AMP Talos. Now, at this point, when these three are run, and if it's not seen that this is still an unknown, what it'll do is send back to here unknown, and you can block it technically, but I don't see anyone doing this. But so what it'll do is it'll release that last bit. If it is determined to be malware, it'll send a reset packet as that last one, and that download will fail on the user's side, and it'll just continue to block that file from then on from the ASA. It's not going to send that hash to the cloud every single time. It will cache it for a certain amount of time in the firepower. Now, the advantage of doing it this way is that you're not storing or updating signatures locally on firepower, or you know, that can get very bothersome to do. And this cloud is constantly updated. It's constantly adding information and threat intelligence. So as it sees new behaviors and zero-day attacks, instead of having to update things as things are happening in real time, that cloud is going to constantly look at your stuff. Now, if you had a previous SHA value that was sent that was defined as clean, and the AMP Talos Cloud later finds out that was malware, like it was just something that was masked somehow, and you know, it set off like maybe a time bomb of malware later on, it does something called retrospective analysis, so a retrospective event. So it sends a, you know, an alert back, retro, I can type, sorry, retrospective, and it sends that back, and it basically, from that point on, the ASA logs that hash is a piece of malware. It blocks anything further from coming through with that same hash, and it alerts you that this event happened, what date, what user downloaded it, and you're able to remediate at that point. Now, going back to this whole thing with all these things, if they have been determined at that point that it's an unknown, it's going to still send that back and that user can download. But what it typically does is this file is under, I believe, 10 megs or 20 megs, it'll send it up to the, based on if you configure this in your policy, it'll send it up to the threat grid cloud. And what threat grid will do is it will basically run this in a sandbox and do a report determining whether this based on a series of behaviors and how it acts, it can kind of detonate this file in that safe environment and determine if this is a zero-day attack. Usually within 7 to 10 minutes, you get an answer on that. And you can see the report inside of Firepower and see if that file is you know, how it behaved once it was downloaded. You know, it gives it kind of a score of how it behaved. You can get very granular in your file and malware policy, basically saying that only sandbox certain kinds of files, because, you know, why would you want to sandbox a you know, something that could be like a JPEG or something. So JPEGs can vary wildly, and you're probably never going to, you know, always match those one-to-one anyways. So to define the malware and file policy, you go to Policies, Access Control, Malware and File. So in my current policy right now, I have, I'm going to go ahead and look at certain file types, and what block malware means is it's going to do the check in the cloud and potentially threat grid as well. And if it's determined to be malware, it's going to go ahead and block it. And I selected only certain file category types because I don't really need to send system files or graphics or multimedia to the cloud to check. Yes, I mean there are things that could potentially be hidden in there, but I'm going to play the law of average, because if you send everything to the cloud, you're going to be sending a lot out if it's determined to be unknown, especially if it's graphics. So I'd rather err on the side of caution. Now here you can you know, define which checks you're going to be sending. So Spiro is for MS executables. That's the metadata I discussed before. Dynamic analysis, that's sandboxing. So if you want to be able to sandbox if it's an unknown, you have that that ability to do so right here. You just check that, and if the file's an unknown, it's going to do that. This is capacity handling. I don't have it set on here, but it's basically it'll store the file if it can't be submitted to dynamic analysis at that moment, and it'll send it later on. If it's local malware analysis capable, you can do it, but I'm not going to do that on an ASA. And if it is determined to be malware, you can reset the connection, and that's just going to be how the response is. If you don't reset it, it'll just spin and spin and spin. You can choose to store certain file types, maybe for forensics reasons, but it is kind of could easily, if you have a very busy environment, it's going to get your hard drive full fast, and it'll purge the information historically, but you don't really want to have to do that unless there's a real use case or testing that needs to be done. And then underneath that rule, I have a rule for just detecting files. So all it's going to do is, take a look at the kind of files coming in, and I can kind of drill into just the file types people are downloading, what's the most downloaded type of file, what users are downloading the most files, and see that. Another thing you can do is any of these policies, you can define which protocol is going to be, if you want to create a specific protocol or rule for HTTP, or maybe if you have like a iron port for email and you want to bypass SNMP, you can just sit there and say, you don't want to, you can define that you're not going to be going through and like trying to check malware. So you'll create a policy that just says detect files and move it all the way up, because if you're having your ESA doing like advanced malware protection, there's no reason to be inspecting all those files again as they're hitting your firepower. So you might create an exclusion rule that overlooks any of those attachments if it's in an email. Let's see. The advanced tab is so first-time file analysis is if firepower's never seen that file before coming through your environment, and it is defined as an unknown, should it send it to the directed grid cloud? I like to check yes. Can't really see a reason why you wouldn't want to do it, because whether it's being seen the first time or the second time being downloaded by your users, malware is malware. I don't want anybody being able to download it, whether it's the first person downloading it or the second person. Enable the custom detection list. So as you recall, I added my notepad to the custom detection list. So if I wanted to prevent certain files from being downloaded on your network, I added the custom detection list in the object management, and I just click here and it'll detect that list. It'll use that custom detection list automatically. The clean list is basically if you want to completely bypass, malware checks, you add something to the object management for the clean list. Based on the threat grid score, what you want to define as the bar for malware. Very high is typically a good thing. I would still inspect archives. Typically, malware is only a couple megs in most cases, but hiding them in archives or encrypted archives, you may want to block encrypted archives or uninspectable archives. Depending on how high security your environment is, it might be perfectly reasonable to do so. But I would always inspect archives, because you don't want something being slipped through by just being zipped or something. The cool thing also about this is if you have AMP for endpoints currently configured, you can actually add either the AMP public cloud, or you can add a connection for a private cloud if you have a lockdown environment where you have an AMP for endpoint private cloud sitting in your environment that's completely cut off from the internet. You can actually redirect your AMP, your dynamic analysis, or your AMP checks, actually, I should say, directly there. For your dynamic analysis, if you have a private one as well, like a threat grid appliance, you can add that here and have that redirected there. Now, I don't typically see this, but I could see it in a DoD environment. So if you've got DoD where certain segments of their network are completely cut off from the internet, you're not sending files to the internet because you have privacy concerns or like SHAs of it, I can get that. Or even financial companies may not want to be sending stuff for dynamic analysis, even if it's getting deleted or whatever ever after. There's certain compliance things like SOX and PCI where you just don't want it to get sent out. So you have that option of putting an appliance on your site and using it that way. When you use these file and malware policies inside of your access control policy, it's pretty simple. So in the case of dynamic analysis and your your file and malware policy, what you can do is you can create multiple file malware policies based on different segments of your network. And let's say you have a guest network where you don't even want file policy to be looked at. You can create a rule, put that above everything else, and then you have a PCI host network that never, and you don't want them ever using the file policy. You don't have to actually enact that. You can just say, I'm going to use the IPS policy for this. Define that as, my zone would be, maybe a DMZ, or just my source network would be DMZ. If that's the case, it will just hit the inspection rule, or maybe a custom IPS policy, and that's it. No file policy. I just put that above the rest of it. If I want to be able to use my file policy for my regular data VLANs, like my users on my network, or corp data, I can sit there and define my subnets for that. As a source one, I can remove my DMZ one. I can define the intrusion prevention policy, the file policy that's going to be enacted there, and it'll only apply to that certain source subnet. Now, someone at the beginning of this was talking about blocking a certain host from being able to get on the internet. Now, security intelligence wouldn't be your only way of doing this. This is where I would create a rule. So, deny internet access. I can block with a reset. And for example, this could be a specific client I want to add in there, and the destination is going I can just set up anything like the internet, any internet access or anything going to the external zone. I could actually say destination zone, and the network is going to be maybe my DMZ. Not going to have that. So I can create this rule where it blocks anything from this source subnet going to the destination zone of external. If you wanted to, you create a simple network object with just one IP address, and doing so, you'll be able to block just that specific IP. So that's like, let's say that's the IP address I wanted to block. So that client going out to external zones, I want to block them with the reset because they should never be going to the internet. And let me go ahead and log to make sure if that user ever tries to reach out, I'll get an alert about it. So that would be how I would block a specific host or a subnet from accessing the internet. Does that make sense? All right, I think we're at the almost 2-hour mark. I actually thought this one was going to be a lot quicker. Sorry about that. So finally, I guess I should ask any other questions before we wrap this up. I see here, for dynamic analysis, do you have to have a threat grid subscription? No, you don't. Threat grid is part of the licensing, as I said before, and for that, you can you just have to have an AMP license on this Firepower appliance. So if I go to System, Licenses, Classic License, or Smart, whichever one, but you just have to have that AMP license to be able to utilize dynamic analysis, so malware. How does AMP do one-to-one checking on polymorphic malware? It doesn't. It does the ethos, which is fuzzy fingerprinting. And if that doesn't work, if it's unknown, if it still hasn't been seen, it's not associated with a malware family based on being a file closely related to that. It could also be checking doing a threat grid analysis of that file. Any other questions? I'll give you guys a minute. Okay. Somebody said, I thought there was a limit to the analysis if you do not have a subscription. Not anything that's published that I'm aware of. So if threat grid, look at the there is a published number, and I'm sure there's the threat grid cloud has a limit to some degree, and your bandwidth has a limit, but dynamic analysis connections. So we're looking at the config guide right now. So as far as the config guide, I'm not seeing anything here as far as a limit, hard limit at least. If I'm sure there's something out there, but I mean, they do limit also the size of the files you can send up there. I mean, 99.99999% of malware is under 5 megs, and the amount that you can actually download, you can configure it here. Let me show you. The size of the file you can kind of tweak a little bit if you don't want to stress out your bandwidth or send files that are too large. But in your actual access control policy, I can actually modify this right here by going to the advanced settings. All right, so minimum file store. Yeah, so you can limit the size of the file that's being sent up there, the amount of the hash, minimum file size, and the maximum file size for dynamic analysis. So there's a lot of tweakings you can do, but typically probably leave it at their defaults and you'd be fine. But if you're doing this on a very low, a link like a T1 link or something like DSL to the internet, obviously you don't want every single 10 meg file getting sent out to have issues and congest your link. So there's some tweaking you can do here that kind of makes it make more sense for you. And if there's only a couple sites where you have those smaller links, you don't have to just limit your whole thing. What you can do is you can duplicate your policy and just apply it to those appliances or those ASAs on that site. So it's a duplicate policy. Everything else in those policies are a complete match. The only thing different is the amount of the size of the file that's going to the threat grid cloud. Any other questions? Awesome. Thank you guys so much. It was a pleasure doing this for you, and I hope this was well organized and beneficial to you guys. Again, my email address is kmcnamara013@gmail.com. If you have any questions or anything in anticipation to the next class, I'm more than happy to kind of prepare or walk through some stuff. If you think of anything, just go ahead and send it to me or reach out to me on Slack. I'm there always making jokes and being as sarcastic as can be. To any of you guys going to Cisco Live next week, I'm more than excited to see you guys. Definitely check out the routergods suite. There's going to be some awesome stuff going on, which I cannot talk about. So check it out, and I'll see you guys there. Have a good night.